Hello, my name is Adam, and today I'm going to be doing a quick explanation of simple harmonic motion. Before we start, here's a terminology page that explains all the terms used in this video. So we're going to define simple harmonic motion first. Simple harmonic motion is simply defined as an oscillation where the acceleration is always directed towards the equilibrium position and the acceleration is directly proportional to the displacement from the equilibrium position. But what does that mean? It means that the acceleration is always towards the center point and its magnitude increases as the displacement increases. So let's look at an example. So here we have a pendulum with three positions, position 1, 2 and 3. At position 1 and 3, the displacement is maximum but the velocity is 0. At position 2, it's at its equilibrium position, which means that the displacement is 0 but the velocity is maximum. Now let's look at what happens as it oscillates on motion graphs. So the top graph shows a displacement time graph with initially the pendulum being at maximum amplitude, going to 0 at position 2 and then back to negative maximum amplitude at position 3. It then goes back to 0 before going back to maximum amplitude again when it completes the cycle. The second graph shows the velocity against time with it initially being at 0, and then the third graph shows the acceleration against time with it initially being minus 2 pi f all squared a. Now let's go over the equation. So the first equation is the acceleration equation, which is a equals to minus 2 pi f all squared x. The minus signifies that the acceleration is directed in the opposite direction to the displacement x. The second equation is Vmax equals to 2 pi fa. The other two equations are x equals to a cos 2 pi ft and x equals a sine 2 pi ft. These are for the displacement. Now let's look at the energy. So initially the GPE is maximum and the KE is 0, but as it goes towards the second equilibrium position, the KE increases all the way to maximum and the GPE decreases all the way to 0. Now this is my source for this video, and here's my Creative Commons license.